Thanks for coming out. So today I'm going to talk about tails of distribution, which is basically going to have a look at container schedulers and see which one makes sense for you. A little bit about me. I work for Poppet. That's my son. I mostly work from home because my team's based in Belfast and Portland, so he helps me. I'm a Docker captain, so I work with Docker closely on all their projects, and you pretty much can find me on the internet as Scotty C, except for Twitter, someone took that. Oh, sorry, that's my full name. So basically, I spoke at Container Camp last week, and Brendan Burns, the director of engineering for Azure, said that containers are a solved thing. So basically, that will be the mechanism in which applications will be deployed from now on. So if we're moving towards that, what other options? Other problems is that going to bring up? So how do we distribute those applications? How do we make them highly available? How do we make sure that they're there all the time when the business needs them? So we're going to look at what options we have in this particular talk. So we're going to break it down into three particular parts. We're going to look at the orchestration layer, which is extremely important because the orchestration layer will determine the architecture flowing down to the next two topics. Since probably for about a year now, the major players in the container orchestration have splintered, and there's quite a difference between the architecture and deployment mechanisms, network layers, and persistent storage you can use, depending on which one you choose. So let's look at the orchestration layer first. So as I mentioned, Brendan said, if we decide to containerize a new unit of application, the orchestrator should abstract the complexity of the underlying infrastructure. So basically what that means is the orchestrator's job is to schedule containers where they go, look after high availability, look after failure, look after load balancing. So all that should be the job of the actual scheduler. And as we'll see in his talk, they both do it completely separate ways. So we basically have two major choices. I know there's more than two, but in my experience talking to customers, these are the two that come up. There's OpenShift, which is Red Hat on top of Kubernetes. So we'll just talk about Kubernetes, and you can take OpenShift as the Kubernetes family because it's basically just like a couple of interfaces built on top of Kubernetes. And then you've got Docker's offering. There's also DCOS and Mesos, but we don't get as many customers talking about that, so I won't really talk about them today. So why is the choice so important? They've got different deployment methodologies. So how you actually structure your code for your containers when at deployment time is completely different. So that makes them architecturally different from the application's point of view. So when you're scheduling an application on the scheduler, they react differently due to service discovery and other load balancers and things like that within the scheduler itself. The networking stacks are completely not interchangeable. So if you go for Kubernetes and you choose a networking stack that works on CNI, it won't work on the Docker Swarm. And another big one that comes up is the distributed key value store in Kubernetes. You have to deploy and look after yourself, where Swarm mode looks after it for you. There's pros and cons to both of these, so we'll go through that. So let's have a look at Kubernetes. Here's a bit of dry reading for this afternoon. That's the architecture of Kubernetes. So basically it's broken up into like a couple of major things. So you've got kube-control, which controls it. You've got the API server, scheduler, replication controller, and then workers. So it's basically a very similar architecture from the outside to what Swarm looks like, but there's a few more moving pieces in this. Actually, I'll go back. So one of the things that you'll see here is, no, you won't. I didn't put it in there. That's all right. I'll talk about that later. Kubernetes has an idea that applications should be wrapped in a certain way. And those certain way are called pods. A pod can be a single container, or it can be multiple containers that make sense for the life of that application stack. So you can have you could have a service that has replications of your web front end, and you could decide that that's going to be one pod. And then you could have your middleware as a pod, or you could have those actually as the same pod. It's an architectural decision within what you deploy. And the choices of splitting them out could be you need load balancing between the two. So if you have a look here, this is what an elk stack looks like as a pod. So here I've made the decision that I'm going to deploy the whole elk stack as one single container each. It's going to have Elasticsearch, Logstash, and Kibana. So it's all there as one pod. So you just define it, and that pod, I would call it elk, or I could call it logging, or I could call it whatever. And I would deploy that to my Kubernetes cluster, and there would be one of each, and it would run, and everything be happy until something died. So this was the first interface that Kubernetes built to tie applications together. But they saw that it was flawed because if there's failures in the pod, how does it reschedule? So they basically come up with services. So what services allow you to do is tag an application name and then specify if you want the service to be running or not. So basically what would happen in this is if the default container died and you had it as a replica set to 1 or 2 or whatever number you wanted, when the container died and Kubernetes saw that it was dead, it would actually restart it. So it would constantly have that service running for as long as you define the service to be running. So this was kind of different to pods. So what is actually happening under the hood here is the service defines a pod, and if that pod fails or part of that pod fails, it will restart the pod. But then they ran into limitations of that, so they did deployments. Deployments create multiple services underneath it, so these are multiple abstraction layers. They create multiple services underneath it, which creates multiple replica sets, which create multiple pods. So it's like the top level of your application fanning down. And then the difference between deployments is you can set the number of services that you need per deployment, so you can have abstraction on the higher level. One of the big drawbacks, depending on where you look at it, is that etcd needs to be configured for the cluster to work, and you have to control that. It's based on Raft. It's a dependency for Kubernetes. You have full install of it, and it's API-driven, but it's a double-edged sword. Because it's the key value store for the whole of the cluster operations, if you have some security concerns about any of the cluster metadata has to be encrypted, then etcd is probably not a good choice. Because encrypting the key value store for etcd can be quite troublesome to unencrypt that every time the Kubernetes cluster needs to make a change to where everything is living. So this is a big overhead. And another thing is that if you're running major clusters and you actually care about keeping the cluster up and running, so you're not doing blue-green, or you're treating it more as like something that you want to maintain, I would suggest, if you ever use distributed key value stores, you take backups and test the restores so you can restore the cluster state. It can get out of sync, and Raft can be you can find in Raft that you can lose consensus and the wrong node becomes the leader, and then it can kill your cluster. So that's one of the things with Kubernetes that I find for most people, the complexity of it outweighs the value of them actually running Kubernetes at the scale they're running it at. So it's just something to be mindful of. So choice 2, Docker Swarm. So Docker Swarm has taken a completely different mindset of the way to schedule clusters. They basically looked at it from not so much an ecosystem point of view like Kubernetes, but from a usability point of view. They put the Raft consensus and the key value store inside of the engine itself. You don't need to worry about it. They've also taken care of security like TLS. You don't need to worry about that. It's got key rotation. You can set the key rotation time. So all out of the box straight away, all the operations of the cluster have got TLS on by default. All the communications to the worker nodes have got TLS on by default, and the Raft consensus key value store is encrypted by default. So what they've looked at is making it really simple to use, but giving you some really cool stuff working in the back end. The key value store is, again, built off Raft, but it's built off Raft that they've modified a little bit. And it uses Gossip as well to talk across the network. So one of the things that it's got is key rotation built in. And if you have a chance, when the YouTube video is out soon from Container Camp Daigo, I always forget his last name, he'll kill me, the head of security for Docker, he done a really good keynote on the key rotation, and he can explain it heaps better than I do. But there's a CA in there, and then it creates a sub-CA. Off the sub-CA, it then leases. If that sub-CA gets taken advantage of or gets compromised somehow, the cluster can actually, you can change the root CA and the cluster will keep running. So they've got like man-in-the-middle attacks covered, Eclipse attacks, there's a whole heap of stuff. He goes into it in great detail. Check out that talk if you want to know more about it. But basically, the cluster looks after this out of the box. So you don't have to worry about any of the so any of the security concerns that you would have to worry about if you had Kubernetes, all this sort of stuff you would have to configure yourself. Which, depending on like where you sit and what industry you're in, this could be a really great value add for you. If you have a team, like a security team that wants to use their CA, you can actually offhand the CA externally, and as long as it can automatically use CRL to get the certificate, then you can still use the functionality of the automatic key rotation within the Swarm cluster. And this is what a stack looks like in Docker. So Docker has made it a lot more simple. This is a compose file. It's also in YAML. And this basically just says Redis and a Postgres. So there's not much to it. It would automatically schedule the stack to have the amount of apps running. So there'll always be one Redis, there'll always be one DB. You don't have to specify it. But if you wanted to scale it, you can then go in and scale it afterwards. There's a scale up and scale down command. But by default, it doesn't have the complexity of pods, services, and deployments. But with that complexity, you can solve more higher level tasks. So it all depends on what sort of application you're deploying and the complexity of the containers that you're running. And I think possibly there's room for both to exist. I've ran both of these in production, so the right tool for the right job. If we go into the network layer and we look at trace 1, I'm not going to go through all this, but Kubernetes has the idea of ecosystem. So basically, they created the CNI, which is the Container Network Interface. And through the Container Network Interface, you have all the options in the world. These are just a few. I'm not going to go through them. But each one of these is configured differently and has different networking controls, depending if you need stuff like BGP, VXLAN. You need to understand the trunking natively from like the physical network all the way through your cluster, or you just need container communication. So everything's covered here. It's kind of like OpenStack in a way. Like you can pick bits and pieces you need. You have to find the right one that suits your need. There's not a solution out of the box that I know of that's a turnkey for Kubernetes. I think Flannel is what most people use for a turnkey, but Weave's also popular, and then they've got Contrail, Open Contrail, and then there's Contrail from Juniper. Kubernetes also has an Ingress container that works. So basically, that's your front end. Works very similar to the way AWS does with Ingress and NATs. Basically, this is a diagram of what it looks like. So you've got Ingress service. You can have multiple load balancers between services. But that's basically how the routing works inside the cluster. What Kubernetes allows you to do is design and implement a lot of complex networking inside the container space. So you can set up things like BGP and things like that actually within the scheduler itself. I'm not sure how many people are working at scale that would actually need that, but these are the sort of options that are available through Kubernetes for you. And this is sort of how service discovery works. So service discovery works with a service called kubedns. When a service is named, it gets a record, a DNS entry, and then containers can find each other. So no matter where they schedule, no matter what happens, they can always intercommunicate with each other as long as they're on the same cluster. kubedns doesn't span multiple clusters at the moment. I know Kubernetes has the idea of federation, and that's coming, but at the moment it's only supported inter-cluster. So choice 2 is completely different. It's Docker Swarm. Docker Swarm has two sorts of networks you can use. It has the native overlay network or the VXLAN network. I believe Cisco's coming out with a product that bolts into them, and there's a network plugin coming, but as I'm talking now, there's only two. So basically what they've looked at is the majority of use cases and defined a network type that will work for like 90% of people. And it also talks to the backend Raft consensus, the Raft cluster, and gets consensus through that. Also, all your communications for where things live on the Raft distributed cluster is encrypted as well, where all the other networking providers in Kubernetes put it in etcd and it's in clear text that you can curl, depending if you set up OAuth or not. So basically what Docker does is it sets up, there's ETH0 on the box, then it sets up Docker 0, and then underneath that it creates VEEFs. Those VEEFs are in the networking namespace, and then they show up inside the container as ETH0 inside the container. So you can see there that the two containers can talk, and the outside world and remote network can talk to it. If you need something a bit more complex and you want to segregate them using VLANs, this is exactly what Docker would allow you to do. So it allows you to do VXLAN. So you can see the two VLANs there. It creates ETH.0.2 off the ETH, so virtual interfaces, and routes the traffic through that. On the back end, it's using the VEEF as well. So this diagram's missing it, but there's a VEEF there that mounts in the network namespace to ETH0 inside the container. And DNS service discovery as well is a lot more simple in Docker. So basically what they've done is in every container they have a DNS server on 127.0.0.11. When you create a container name, that's the DNS name. The DNS name gets propagated across all containers on that Swarm cluster, and that's how they intercommunicate. And that runs in the engine itself. It's not an externalized application like kubedns is. So that's the difference with how service discovery works. And again, all of this is kept inside Raft, and it's encrypted. So all your DNS records are encrypted if someone got into the cluster manager and tried to find out where everything is. So they both have the idea of load balancing, except Kubernetes has the Ingress into load balancers. Docker has mesh routing. So basically what that means is on the Swarm cluster, you can hit any of the nodes on the port, and it'll route the traffic to the right container, even if it's not on that host. So you can put like any load balancer in front of it if it spans like multiple nodes, and you can hit something on port 80, and even if it's not on that port, it will go to, even if it's not on that host, it will, Swarm will route to the right host. The only limitation to this is when you have multiple things listening on the same port. So it doesn't do layer 7 routing, which a lot of people get confused about. So if you wanted to do layer 7 routing, you'd have to have something that understood the HTTP headers and did that routing at the front end. So if you had two services running on port 80, there is an application created by Evan Hazlett that's a sysadmin at Docker called Interlock that will actually listen to Swarm events. And then you can put, it's an Nginx container that sits in front of it, does the HTTP headers. And when Swarm moves a container, it updates Nginx without having to reboot the Nginx container. So it does it all dynamically in the background. So there is some things that Docker are looking at implementing, so you can do layer 7 routing, but Swarm by itself doesn't do layer 7 routing, which people sometimes get confused about with mesh routing. Because originally it was called HTTP mesh routing at DockerCon 2015, and it didn't actually do HTTP headers, so they just changed it to mesh routing. Persistent storage is an interesting one inside the container world because most of the containers you hear about, or containers you hear about are microservices that don't need state, but not all applications can do that. So Kubernetes supports persistent containers. So mostly it supports them in the host path, which is just mounting it to whichever host that container is running on. They natively know cloud. So Kubernetes can talk to GCE, of course, Google. It can talk to AWS for EBS. I'd say that it'll be able to talk to Azure very soon because they're pushing Kubernetes as a service really, really hard. It understands OpenStack and VMware storage, so you can natively mount a container data store to either one of those, or you can get something third-party like Portworx. The beauty of doing this is you're able to separate the data on the container if you go for something that's like an actual storage away from the compute. And if that compute node fails and it restarts the container on another server, it will then have the data mounted in the external volume. So you're basically splitting up the compute and the data. So I know there's Oracle spoke before. They've got Rack that you can run in Docker now. It's on the Docker store. They use some things like this, like Docker volumes and a few other things. There's a few other things that use storage in the container world, and seeing now that people are looking at containerization more, I think we'll see this particular issue come up more, because you can get a lot of good value by containerizing applications and securing the kernel, so there's multiple things running. But if you have all those things, most of these applications will need storage at some point. So I think there was a really good company called Flocker. I thought solved this really well, and they actually went bankrupt earlier in the year. And it was actually because I think they were too early in the market. Like, not enough people knew that this was an issue, and yeah, they couldn't get VC funding anymore. But they had a really, really neat solution. You could actually offhand the SSL to Vault and do calls and a whole heap of security stuff. It was really good. So that's Kubernetes. Swarm, unfortunately, only supports host path and NFS. In saying that, Docker did acquire a storage company late last year, and I know in the works they've got something coming out from them, which will allow, at least the first release will allow image cache across the Swarm clusters. That's still a problem Kubernetes has, that there's no shared image cache across. So if you want an image, like a container image, OCI compliant or whatever you want it to be, it has to be on all nodes, which is like kind of a waste of space. But Docker is looking at that problem now. Will they be able to natively support like the cloud providers? Not sure if that work's being done yet. As I said, Flock is still open source, so you can use that. It just won't be supported anymore. I believe Rexray, you can do it, but I'm not sure how good it is. That's from EMC. But yeah, persistent storage, Kubernetes has solved that better. So what's the best tool after all this talk? I don't know. I think both have got really good features. I've ran both, as I said, in production, and it's the right tool for the right job. So if you're doing, like, say, an application that's written in GraphQL that's doing a lot of front end and a lot of batch job, I would probably go for something like Kubernetes. If you're running something that's in a more compliant area that you need some sort of security controls and wrappers around, I would go Docker Swarm. And that's what I've done in the past. Because, yeah, some of the operational concerns around Kubernetes, like if you need to change SSLs that's inside the cluster, it's actually easy to deploy a new cluster and put the workload across than it is to change the SSL. Docker handles that out of the box. So you just got to think about stuff like that. Some of that stuff hasn't been solved yet inside Kubernetes. That's been solved inside Swarm. But on the other hand, Kubernetes can do a lot more complex networking, routing, and handle distribution at probably a larger scale than Docker Swarm can. So yeah, that's pretty much my talk. Any questions? Oh. Any questions?
There are always questions. Well, I want to follow up and just ask, what are you most commonly asked when you're describing these two top choices?
It depends what customer I'm talking to. A lot of people ask about support, and that's why I think OpenShift is so popular, because it's Kubernetes that support it. Google has a hard and fast line that they don't support software. That's an open source software, and even like some of the engineers for Google were at Sydney last week talking at Container Camp, and their idea was learn the software, get into it, contribute. You shouldn't need support. Which isn't always the way that enterprise can work. So Red Hat has made OpenShift, which comes with support. Docker has a supported product as well called UCP that runs on top of Swarm. Both of them have like pros and cons. But yeah, that's the major thing, that people have heard a lot about Kubernetes. They want to use it, but then they're maybe in the enterprise and their like CTO or whatever is like, where do we get support for this? And yeah, it's not really a product that's being supported by it. There's a few little vendors as well. So yeah, Red Hat, that's where Red Hat comes in with OpenShift. I didn't really want to talk much about OpenShift today because it's just built on Kubernetes anyway. Yeah.
So there's a push to play around with deploying OpenStack using Kubernetes. Do you think actually Docker Swarm will be a better fit for that type of OpenStack?
Repeat the question.
So basically we heard a talk earlier today that it was deploying bare metal, then deploying Kubernetes, and then deploying OpenStack on top of Kubernetes. Could you do that on Docker Swarm? I only quickly had a look at the containers like just before this talk because I'd never heard of doing that before. You could use Docker Swarm. I don't think there'd be any plus or minus in that to using either or. Yeah. I would actually probably say if I was going to do that, if I was going to run OpenStack in containers, I'd probably try to run it on top of Containerd and run C, and I wouldn't have the engine or any of that. Because yeah, it's a lot lower level, and you want to speak to the underlying hardware. It looks like they need to be privileged, so.